Question 22. Evaluate integration, the definite integration from e to 2e of 1 over x dx. Here it's a direct question and it's very simple. We'll just integrate this expression and then we will substitute by these values, then subtract by the first value, then substitute by the second value, then subtract to find the final answer. So the first step, we have to integrate the expression. Integration of 1 over x. Here if we have a form of fraction like this, 1 over x, and the numerator is the differentiation of denominator, then the integration will be ln of the denominator, but don't forget to put absolute value sign. So here the integration of 1 over x equal ln absolute value of x. But this part will be converted to bracket like this and put the values here. So we'll substitute by the first value, then substitute by the second value, subtract. So the first one will be ln of 2e, the second will be ln e. Here the first one minus the second one, so it will be ln 2e minus ln e. Here we can remove this sign because this is positive. 2e is positive and e is positive, so we can remove this absolute term sign. As we said before, from properties of logarithm, that ln minus ln equal ln of divide, so it will be ln 2e over e. By simplifying, cancel e with e, it will be ln 2. And if you want to write as decimal, it will be 0.693. If he didn't ask to write as decimal, you can cancel this part. Question 23. Find the area enclosed by the curves y equal x minus 1 all to the power of 2 and y equal root x minus 1. Here he gives the two functions and he gives bounds of integration. If he didn't give the bounds of integration, we have to put y1 equal y2 and solve to find values of x. But here it already gives bounds of integration, which are a and b. Then we'll use the rule direct. It's integration from a to b. It will be from 1 to 2, and the rule is written already in the formula sheet. We can write it first, then substitute. y1 equal, or will be root x minus 1 minus x minus 1 all to the power of 2 dx. We have to integrate this expression and substitute by these two values, 2 and 1, then subtract to get the value. The value we'll get is the area. Before integrating, as we said before, we have to simplify as we can. Get rid of root, denominator or bracket. Here we have root, so we have to change its form. It will be x minus 1 all to the power 1 over 2 minus x minus 1 all to the power of 2 dx. Here we have two parts, so we'll integrate each part separate. It will be x minus 1 all to the power of 1 over 2, as we said before. To integrate bracket with power, the rule is add 1 to the power, divide by the new power. But in case the bracket is multiplied by differentiation of what inside the bracket. Differentiation of what inside the bracket is 1. Here it's already multiplied by 1, so we can apply the rule, add 1 to the power, divide by the new power. It will be 2 over 3 x minus 1 all to the power 3 over 2. The second part, it's the same or similar. Bracket with power, will add or apply the rule, add 1 to the power, divide by the new power in case the bracket is multiplied by the differentiation of what inside the bracket. Differentiation of what inside the bracket is 1, so already it's multiplied by 1. Apply the rule. So it will be 1 over 3 x minus 1 all to the power of 3. We'll substitute 1 time by 2 and 1 time by 1, then subtract to get the answer. And we have to write the substitution. 2 over 3 multiply 2 minus 1 power 3 over 2 minus 1 over 3 multiply 2 minus 1 power 3. It's 2 over 3. The second one, two over 3 multiply 1 minus 1 all to the power 3 over 2 minus 1 over 3 multiplied by 1 minus 1 power 3 equal 0. Here it's in this part it's 2 over 3 minus 1 over 3 equal 1 over 3. Here it's 0, so 1 over 3 minus 0 equal 1 over 3. Sorry, in this part, or the value of this expression, 2 over 3 minus 1 over 3. So the final answer will not be 2 over 3, it will be 1 over 3. So the value of the first substitution minus the value of the second substitution will get 1 over 3. 1 over 3 is the value of the area, units square. Question 24. When the area enclosed by y equal r, the x-axis, and x equal h is rotated through 360 degrees about the x-axis. A cylinder is formed with radius r and height h. Show that the volume of the cylinder is given by pi r power 2h. Here is talking about volume of revolution. We know that the rule of volume of revolution is integration from a to b pi y to the power of 2 dx. We have just to put values of a and b and the expression y in its place, or the function in its place, and integrate, substitute to find the value as we did in the definite integral. Here values of a and b. Here these are bounds of area, or bounds of integration. The area starts from this point to this point. This point we already know that it's 0, it's original point, and this point he said it's b, it's h, sorry. So this is a and this is b. So the value of a is 0 and the value of b is h. So we get the first information, which is 0 and h. Pi can be written inside the integration or outside, it's the same, no problem. What is the value of y? The value of y is already given. It's r, so it's r power 2 dx. Just integrate this expression and substitute by h and 0 to find the area. Here, if we want to integrate this expression, don't do this mistake. Don't say pi will be the same. Don't say integration of r power 2 is r power 3 over 3. It's wrong. Why we did this? Because here we apply the rule of differentiation or the rule of integration on the variable of the function. Here, what is the variable of the function? The variable here is x. So any expression or any part without x, without letter x, it's constant. Whatever it contains other letters or not. We said before, any term without the variable is constant. Its differentiation equals 0 and its integration just add the variable. So here the integration of pi r power 2 is pi r power 2 x from 0 to h. We'll substitute by h and substitute by 0, then subtract. So it will be pi r power 2 h will be pi r power 2 h. The other one, pi r power 2 multiply 0, it will be 0. If we subtract, it will be pi r power 2h, and it's the same expression. So here we have to pay attention. If we want to differentiate or integrate, we have to check there's a variable or not in the expression. We said constant term means a term without the variable, not term without letter, because we can get a term with letters but it's constant. Constant term means its differentiation equals 0, its integration the same, just add the letter or just add the variable, as this question. Here r is not the variable, so we'll not apply the rule of integration, which is adding 1 to the power. Divide by the new power on letter r.